Hi guys, and welcome to the third video on Swift in Module 3 of Introduction to iOS Development. Since I signed off on the last video, I've tried at least 10 times recording this next video and ran into a fairly persistent bug in Xcode, which I mentioned last time and thought I'd solved, but had not solved, of certain daemon processes, specifically diagnostic daemon and home daemon, taking tons and tons of time, running super high CPU percentages, like 150% CPU, whenever I tried to run an Xcode playground. Since then, I've tried upgrading my operating system. I upgraded Xcode from 9.3 to 9.3.1 to 9.4. I deleted the old versions, and some combination of doing those things seems like it may have fixed my problem. But just in case it hasn't, I've departed from my normal way of doing this class where we go through the code live and pre-recorded or pre-entered the playground that I want to show you to make sure it's all, so the output's all there so that I don't have to sign off and start another video, or tap dance till it finishes, or kill Xcode and restart it if things do hang up. So let's pick up where we left off. At the end of last time, we were talking about optionals and unwrapping them and implicitly unwrapping them, and we were, I believe, right about here. We had declared x5 to be an optional integer. We'd played around with that some. We had declared x6 to be an implicitly unwrapped optional integer, and had looked at what things look like with that. In particular, we said that if you wanted to treat x5 like a normal integer value, you had to unwrap it before you use its value. Whereas with an implicitly unwrapped optional, you don't have to do that. The right value will just show up. So from there, where I'd like to go is talking about control flow, and let's start out. We'll just print an old string. That we had declared way up toward the beginning here. str1 had the value of New Hope. So just sort of recalling the value of that. And I'm going to create an if-then-else statement, and here it is. This is the syntax of if-then-else. The parentheses here are actually optional. They don't make any difference. You can get rid of them. And so I said, if string1 equals a New Hope, then print yes, else print no. And you can see that what it printed over here was indeed yes. So at first glance, that might seem sensible, except when you think about it, you'll realize that Swift is treating strings differently than they're treated in some other languages. Equal equals between two string variables is checks if they're character by character the same. It does not check that they are the same object. It does not mean equality of reference. It means equality of value for string types. Okay, and you've got all the other usual less than, greater than kinds of operators, and, or, and not, if you want to use them in your Boolean conditions. Here's another control flow construct, a for loop. Earlier versions of Swift had a for loop that looked like the kinds of for loops you would see in Java, C, and C++, where you have the statement to initialize things, and this would look like for I equals 1, I less than 10, I less than equal to 10, I plus plus. If you try that anymore, you'll be told that that's been removed as of Swift 3. So in Swift 4, where we're working now, you have to use an expression like this, which is called a subrange. And in fact, you can declare a variable to be a subrange, and I do that down here. I declare S to be this array 1, 2, 3, and I can say for S1 in S, print that value, and you can find it down here in the output. Let's see, where were we? First of all, we'll go up right after we printed yes. We went into this for loop, which should print the numbers 1 through 10, and that happened. Then we declare a variable j to be an integer value 0, and we go through a while loop and print the it'll print the values 1 through 10 again. So that works. And then we print the last value just to show you what happens to a while loop variable, and the for loop variable's scope is captured, but the while loop's just a normal variable, so we can print its value. Then we go through the business with another subrange and a for loop indexing with S1 through all the values of array S. We get this little 1, 2, 3 here. Then if you want to check the condition at the end of your loop instead of the beginning, you can use the repeat while construct here. So this sets j to be 1 and prints 1 through 10 that way, 1 through 9 rather, because the while condition is while j is less than 10. So on the 10th iteration, after it prints j9, increments j, it's going to exit from that. And the last control flow construct I want to talk about is a switch statement, which lets you, it's sort of a generalization of if then else. And the general syntax is you switch on a variable and you have cases for lists of the values that variable can take. So here we have a for loop for j equals 1 through 4, and we're going to have a switch on the value of j. If j is 1 or 2, we're going to print j is 1 or 2, and you see that happens twice here for the values of j1 and 2. On the third case, we'll print j is 3. And then just to show it off, I have the default case, which would print anytime none of the other cases run, which would run when none of the other cases run. And so this case it prints j is bigger than 3. And that's sort of a review, a sort of a whirlwind review of control flow in Swift. But basically, that's what you've got: some different kinds of looping constructs, conditional constructs, if then else, and switch statements. So the next thing I want to go to in terms of control flow are the notions of functional abstraction. How do you declare methods and functions? And here's an example of a very simple one. The keyword func, F-U-N-C, indicates that we're starting a function declaration. Then we give the name of the function we're declaring. Then we have its argument list in parentheses with the arguments separated by commas. Arguments look like the name of the argument, followed by a colon, followed by the type of the argument. And if you want to require the user to specify the arguments by name, you can leave out this little underscore. And you notice this was in our action methods, we had this leading underscore. What it means is you don't have to label the argument when you call the function. And it gives you a function call that looks pretty normal. This is the function call for the +1 function with the argument 7. And it causes this line 8 to be printed down here in the output. And we don't have to specify the name of the 7. And this is a change from earlier versions of Swift where naming parameters was handled differently. If you leave off the leading underscore, and this function declaration is just like the earlier +1, it's called +1 v2, The only difference is we left the underscore out. To call that function, you have to name the argument. And in this, so we call it with argument op1, value 10, and it should print an 11, and in fact, it does. The next thing I've declared is an additional function. In this function, I name it area of rectangle. I give it two arguments, which are doubles, width and height, and it returns a value double, and that's just going to be the product of the two arguments. And I don't bother to print these out so that it don't appear down here in the output, but I call the function twice. With 5 and 10, I get the result 50, and with 2 and 4, and I get the result 8. Just to show you what a function looks like that has more than one argument. If you wanted a function that didn't return any value, you can leave off the return type, just leave it out, and that works fine. And the last topic I want to cover for Swift now are the notions of structures and classes. Swift is an object-oriented language, and the idea of classes, I think, will be fairly straightforward. It's really the same idea of class that you would find in Java, C++, C#, those sorts of languages. You can subclass a class, you can create instance variables of a class, and equality of objects and assignment of objects is by reference. That means when you assign one object to be another object, it's really just copying a pointer of that one object to the other object. There's an additional construct in Swift, and if you're an old-time C programmer, the usage is going to be a little confusing here, because they use the keyword struct for structure, and it looks just like a class declaration in that you can declare instance variables, you can declare methods, which are functions in Swift, as part of the struct, the same way you can. I've declared a struct A and a class B that are identical here. Each one has one internal variable and one internal method. The method is named f in both cases, but it does different things. The method f for the struct squares the argument. The method f for the class cubes the argument. So they also initialize ever so slightly differently. But before I get to that, I sort of need to finish talking about what the notion of structs are. The idea, if classes are a reference type, that is where object equality is tested by checking equality of pointers, structs are value types. So if you assign one struct to another, it's going to make a copy of it, member by member, and it'll be independent of the other object. And I'm trying to illustrate that with some code here. First of all, I want to show you how you declare an object or a struct, an instance of a struct. You declare either for objects or instances of structs. You call them. They're just variables. So I say I want a variable named myA. The type of that is A, so I use my struct declaration up here, and I initialize it. Initializer, you get built-in initializers for free with structures. You can write your own initializers if you want, and I'll leave you to research that in the other references for Swift if you want to look them up. But this is just using the built-in constructor, which gives you arguments for each of the instance variables in the order in which they appear, named with their internal names. So this creates an instance of struct of type A, and it initializes its instance variable x to the value 12. And you can see that down here when we print the value of the x instance variable for struct my A. I was making sure we were lined up properly. These 8 and 11s were outputs of the +1 function up above. The 12 comes from here, where we print the x instance variable of the struct my A. Now let's assign it to be 7. Print it again. It's 7. So far, straightforwardly. So far, everything's straightforward. Now we're going to create a variable my B, instance of the class B, not the struct A. We'll initialize it. Now here, I don't give an initializer at all. It's going to take advantage of the fact that I put an initial value up here for that variable. And there, you can get a lot fancier with your initialization for both classes and structs. I'm just trying to get something to work here to sort of get us along and sort of show us the concepts of classes and structs. But initialization is one way they differ. So, and in fact, if I were to put an x12 in here, I'd get an error. So I create an object, my B, of type B, and initialize it. And then I'm going to make some copies. I'll make a copy of the struct my A with another struct my C, and a copy of the object my B with a variable my D, which is going to be of type B by the implicit type inference. Okay, now let's assign some things. Let's say that my C, x instance variable, will assign 2 to that. And let's see what happens when we print x from my A and x from my C. X from my A is exactly as it was. X from my C is still 2. So notice that changing my C doesn't change my A, even though we assigned my C to be my A. What this means is that because my A is a struct, it's going to make a copy. And that my C and my A don't share anything. We're going to do the same thing down here. We'll set my D to be 5. And then I want to look at what happens in my B and my D x variables. And I find that unlike with C and A, now they're both 5. You see that over here and in the output. Because when we assign my D to be my B, what we really get is another reference to this object my B, not a copy of it. Lastly, let's declare a, I want to look at subclassing. So I'm going to define a subclass, my subclass, colon B, and then the body of the class. And then what this syntax is saying is that my subclass is a subclass of type B, so it's going to have all the instance variables and methods of an object of type B, plus it's going to have this new instance variable y, which is a double of type 2.5. And so I can print its value of x and its value of y. The value of x it gets, because it's a B, comes from the initializer up here, and the value of y it gets is from the initializer down here. So we get a 7 and a 2.5 printed for that example. Now that's sort of a whirlwind tour of Swift, but it should give you some introduction to the syntax of the language. Read over carefully Appendix A And for reference, I don't recommend reading the whole thing, but for reference, look at the Swift programming language document on the developer.apple.com website, and hopefully that should clear things up. In the next video, I'm going to cover an exercise I'd like you to do. I'm not going to ask you to do a playground because, well, you can do a playground to get things started, but it's really just going to be a few lines. These playgrounds are immensely frustrating, so what we're going to do is just develop another app, but an app where there's a little bit more Swift code to it. Not a whole lot, just about 10 or 15 lines, but there's actually going to be a model component to that assignment. So I'll see you in the next video.